We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video we'll discuss the problem of the day for 7th of January. The problem name is 1's complement and this problem has been marked as basic. The accuracy level for this problem is 79%. The number of submissions are 6,000 and the number of points awarded for this problem are 1. So just quickly consider giving me a quick +1 in the chat if my voice is audible to everyone and my screen is also visible. And after that I'll start with the problem today, just waiting for other people to join. If everything is working fine, you can just consider giving me a quick +1 in the chat. Right, so this problem has been asked in companies like Cloudera and many other companies. Basically in this problem what you have to do is you'll be given an n-bit binary number. You will be given an n-bit binary number, that is the number of bits in that number will be n, and you have to find 1's complement of the number, right? What does this mean? The 1's complement of a binary number is defined as the value obtained by inverting all the bits in a binary number, right? So if everything is working fine and my voice is also audible, so everyone can just consider giving me a quick +1 in the chat so that I can start, right? So what does this question mean? So this question says that you will be given a number, you will be given a binary number which will be having n bits. Let's say you have been given 101, so in that n is equal to 3, right? So this is the number. What you have to do is you have to flip these bits, right? If it is 101, then what you have to do is you have to do 0, 1 and 0, right? This way. If the problem statement is clear to everybody, then you can just consider giving me a quick +1 in the chat. Okay, right? So this is what you have to do. Like this, if you will see what is the actual number, so if you will say this is 1, this is let's say 2, this is 4, so this will be nothing but something like 5, right? And this is 3, right? So that is how the number is flipping. Now in this case, in this problem, what you can do is you will be having a string that will be s. Let's say my s currently is nothing but 1001 and the n value for it given to me is 4, right? So in this case what I can do is I can start my loop, that is for let's say I have a result that is a string, let's say answer initialized to null initially, right? And in this what I'll be doing is for I starts from 0, I is lesser than n, that is less than the length of the given binary string. After that I'll do an I++. Once I'm done with that, so if my s of I, if it's equal to 0, so if my current s of I, if it's equal to 0, in that case what will I do? In that case I'll simply say that if it's equal to 0, then I need to flip it, so I need to flip to 1. So that is why in my answer I'll say answer plus is equal to 1. I'll add the character 1 to it because I am flipping from 0 to 1. And in the else part what I will be doing is if my s of I is equal to 1, then in that case answer plus is equal to 0, because if it's 1 then I have to change it to 0. Otherwise if it's 0 then I have to change it to 1, right? So is this much part clear to everyone? Just quickly let me know in the chat if this much part is clear to everyone, right? So I hope that this much part of the problem was clear to everybody. Now the question comes that this part is okay, but let's talk about a general situation in this case, right? Let's talk about a general concept of this problem. The concept is that let's say that you have a number that is n is equal to 1001. The naive approach is very easy. Like what you have to do in the naive approach, you just have to let me show you the code part for the naive approach as well. So this is the code part. That is, first you have the string s, then you have its length n, you initialize your string answer to null. After that you iterate from 0 until less than n. If your ith character is 0, then you instead of it being 0 you flip it to 1, that is you add in your answer 1, otherwise you add 0 to your answer, right? And in the end you return your answer. But in this question there can be a second way as well. What is that second way? Let's suppose if I have this particular number, so if I see this number, if I make a number such that it is what is the rightmost set bit, so this is the rightmost set bit, right? So I set every bit from here, so now let me subtract these two. So let me subtract these two. What do I get? Let's say both are in I convert them to decimal form and then I subtract them, right? So in this way what will I get? The binary representation will be the same as this, right? So what does it mean? So this is 0, 1, 1 and 0, right? If I was given n, right? What does it mean? So if I have 1 0 0 1, so what is the representation? It is 1 2 4 and 8, so that is nothing but 9. If I have all ones, that is 1 1 1 and 1, so that is 1 2 4 and 8, so that is 12 13 14 15, right? So this will be 15. And if I subtract these two, so 15 minus 9, that is what I am doing. 15 minus 9, I get a 6. What do I get here? 1 2 4 and 8. So this gives me what? You can see the bits are set at 4 and 2, so that is, this is also 6, right? So in this way also you can get it, right? What is the approach? The approach is that you set the maximum set bit. Like if you have, let's say, something like 1 0 1, right? In this case, what you do is you see what is the maximum set bit. This is the maximum set bit, so you set every bit from here, right? From MSB, that is, this is the maximum set bit in the given number n, so you set this bit as well as all the bits towards the right of your new number, right? And then you subtract these two, so you get 1 0 0, right? So in this case, if you have this number, if you have been given this number, that is 5, then what you can do is, this is 1 2 and this is 8, 1 2 and 4, right? So this is nothing but 7. So if you subtract these two, you get a 2, and this representation is of nothing but 2, right? So this is one of the ways to do it. What I'm basically saying is, you'll be declaring a temp initialized to 0. After that, you will be running like while temp is lesser than the number that has been given to you. And after that, what you will do is, every time you will multiply your temp by 2, right? You will keep on multiplying your temp by 2. Temp asterisk is equal to 2, right? And once you are done with that, so what you will be doing further is, you will be once you have this, like let me show you the code part, like how I am implementing it, like this, something like this, right? Like you can implement it using that concept also and this concept also. In this case, like what you can do is, you can make it as 1, right? Basically you are trying to change your number, like from like if it's 2, then you are changing it to 4, then 8, like this, right? From 1 to 2 to 4 to 8, like where every bit is set like this. Basically you are adding each time. What does it mean? Let me show you in a better format. So like this, if you have temp as 0 and you have initialized your power to 0 as well, so what you can do is temp plus equal to, that is, you are adding to temp power of 2 comma p. That is, first of all you will add 2 to the power 0, then you will add 2 to the power 1, then you will add 2 to the power 2. So all the bits will be set in this number, right after that, what you will be doing is, you will be doing a p plus plus. What does p plus plus mean? So you'll be increasing your power, right? These powers you will be increasing, right? And in the end, what you will do is, you will simply return temp minus the number, right? In this way also you can get it. Now there is another approach, that is the third approach for this problem, and that is using the concept of bits. Like as you know that in this case you have to flip bits, to so then why not use the concept of bit manipulation here? Like there is a operator, that is XOR, right? XOR, there is a XOR operator. Like if you do 1 XOR with 0, so you get what? You get 1. If you do 0 XOR 0, so you get 0. If you do 1 XOR 1, so you get 0. If you do 0 XOR 1, so you get 1. So what is the property of XOR? There is a property of XOR that and that property is that if a bit is set and you XOR it with 1, so it becomes 0. Like if, let's suppose, a particular bit is set, right? Please repeat approach 2. I'll repeat it, just let me complete this part. Like 1 XOR with 1, if this bit is set, if I XOR it with 1 again, so it becomes what? It becomes 0, right? If a particular bit is 0 and I XOR it with 1, so it becomes 1. So this is the special property about XOR, that if you XOR a particular bit with, if it is set like this way, this one is set, if this bit is set, you XOR it with 1, you get 0. So that bit becomes from 1 to 0, so it becomes unset. If a bit is unset and you XOR it with 1, so it becomes 1, right? This is the special property of this case, right? Now next up, what you will be doing is, basically you take the number, and what you do is, like if you have a particular number, let's say 1001, so what is the length of this number? If you consider it taking consider that this is a binary number, let's say if instead of this you were given 1 2 4 8, like if you were given 9, so this is the representation of 9. If you're given 9, so what will be the length of 9? That is log of base 2 and then 9, and I'm taking the floor of this, right? What will I get? So this will be nothing but 2 to the power 3, but the actual length is 4, so that means 3 plus 1, that is I'll get 4, so that is the length of this is 4. If I do 2 to the power 4, what will I get? 2 to the power 4 is nothing but 16. What is the binary representation of 16? It is nothing but something like this, right? It is nothing but this, that is 1 2 4 8 and 16, right? So this is the binary representation. What if I subtract this 16 with this 16? With this 16, if I subtract it with 1, what do I get? I'll get this, let's say 16 minus 1, 16 minus 1, so I'll get a 15. What is the representation of 15? 1 1 1 and 1. What does it mean? That is that it means this 1 1 1 and 1. So all the bits are there, right? All the bits are there, all the bits are set here, right? You can see in this case all the bits become set. So if you take 2 to the power, that is, first of all you find the length. So what is the length? Length is nothing but floor of log base 2 n plus 1, right? N plus 1, that is the length. After that you do 2 to the power length, right? 2 to the power length. Why? Because in that case you will get 16, and you subtract this 16, from this length you subtract minus 1, so you get 15. 15 is what? In this 15 all the bits are set here, right? It will give you the length like this, the length of the number where the maximum set bits are set, and after that all the bits will be set. All the bits will be set here, right? In this case you can see some bits are set, some bits are not, but if you subtract 2 to the power length minus 1, so you'll get this number 1 1 1 1 1. And once you XOR it with this number, so what will happen? Let me show you. If you have this particular number, then once you XOR it, like if this is what 1 1 1 and this is 1 0 0 1, if you XOR these two numbers, so if you XOR 1 and 1, it gives you 0. XOR 1 and 0, it gives you 1. 1 and 0 XOR, it gives you 1. 1 and 1 XOR, it gives you 0, right? So in this case you can see that this particular number got here, it got flipped, right? That is how I'm doing it. For getting this particular number, I first of all find the length. Length is nothing but floor of log 2n plus 1. So I get 16, that is this particular representation. But if I subtract 16, that is the 16 number itself, I subtract it with 1, so I get 15, and if representing 15 looks something like this, that is 1 1 1 and 1, 4 times 1, so that means 4 times 1 is this number 1 1 1 and 1, right? And that is the length of this number as well, right, in binary form. So that is why this will help us, and in that you just XOR it. So that is how you will get it. Like what I'm saying, let me show you the code part for that as well. So what I'm basically saying is, let's say you have been given this number, that is binary length. What you will do is, first of all, floor of log 2 num plus 1. Let's suppose you have been given the integer number n that you have to flip the bits for, right? So in this case what you will do is, mask is equal to long int 1, that this is nothing but you can say power of you can say power of 2 comma power of 2 comma binary length, right? This is very same. Then you subtract it with 1, then whatever mask you get, whatever the number you're getting in which all the bits are set, you XOR it with the current number, and then you will get the number which is having the flipped one, right? So this is one of the approaches. Now Ritik, shall I show you the second approach again? So what I was saying in the second approach is, like let me write it. So repeating approach 2, right? What I have done in this case is, like if I have 1 0 0 1, right? So what is this number? This number is 1 2 4 and 8. So this is the representation of 9. What is 1 1 1 and 1? So this is 1 2 4 8. So that gives me 12 13 14 15, right? This is 15. If I do 15 minus 9, what do I get? I get a 6. What is the binary representation of 6? The binary representation of 6 is nothing but 1 1. This is the binary representation of 6. 1 2 4 and 8, right? So this is 0 1 1 and 0. This is the binary representation. So that is what I'm saying. So if this is if this particular representation is, if you do this, like if you do 1 1 1 1 1, if you, that is 15, if you subtract these numbers, so you get 6, and 6 will have what, 0 1 1 and 0. So you see that this particular thing, this particular was the num that was given to you, and it got flipped, right? It got flipped. And how do you do that? How do you do that? Right, correct. Are you getting this point? You have to flip it like this. So how do you get that? Is there any approach in which we can replace 0 with 1, for example? Like you can directly do it, like in Java you are asking, or in which language? No, for method of Java, basically if the in Java, if s dot caret of I is equal to 0, then what you do, s dot caret of I is equal to 0. If the current character is 0, then you can change it to 1. You can change it to 1, right? You can change it to 1, and if it's equal to 1, then you can change it to 0, right? You don't need a replace function. Basically you can do it by yourself, right? So that is why you don't need it. Okay, I hope that this is clear. So this is what I was telling, right? What I was telling, let's say this is 1 1 1 1 1, this was 1 0 0 1. So if I subtract these two, what do I get? 0 1 1 1. Notice that this is not the difference. Actually I'm taking the difference of 15 minus 9, so that will give me 6. So the representation of this number, flipping the bits, is 6, right? And you can see 1 2 4 and 8, so this is 6, right? So this is what I'm saying. So what I'll do is, I need this number has all the bits set, all the bits set. What do I mean by that? So initially I'll say that, okay, the first bit set is 2 to the power 0. After that I'll add 2 to the power 1. After I'll add 2 to the power 2. After I'll add 2 to the power 3, right? Until it is greater equal to the number. Greater equal to the time complexity is nothing but order of log 2 n. That is the number of bits. The number of bits in the given number, that is order of n. That is the number of bits given in the number, right? So you just make all the bits as set in that particular. If there are 4 bits, so you make all the first 4 bits as set. So you get a 15. You do 15 minus 9. If you have the number 9, then you get 6, and this will be the number which is having the flipped bits, right? I'm talking, notice that I was telling you these approaches for the advanced level of question, like advanced level question. Instead of string, if you are given just the number, then how would you resolve it, right? So I hope that if the problem is clear to everybody and all the 3 approaches are clear to everyone, so please consider giving me a quick +1 in the chat. Let me talk about the approaches as well. So in approach 1, right, in approach 1, what we did was we flipped the bits, right? Flip bits directly. Approach 2, all set bit number minus number minus num. After that, approach 3, XOR approach, where if you a particular bit, if you XOR it with 1, so it flips, right? It flips. That was the concept that we use. So if everything is clear to all of you, like Ritik Maurya, I hope that is clear, and other people, Gaurav is also clear with this. So consider giving me a quick +1 in the chat. Also, if you haven't liked the video, so if you like my explanation, so you can consider giving me a like to the video, and also if you haven't subscribed, so you can consider subscribing the channel. Apart from this, let me tell you one thing more. So like this problem of the day that we had discussed, what was for 7th of December, but today also we have a problem of the day with us, and the problem name is n digit number with digits in increasing order. So you can consider solving this problem. This is the problem of the day for today, that is 8th of January. There are still 8 hours left. If you will solve one problem each day, so that will add to the progress. So if you improve by, let's say, 1% each day, so that will become 37% at the end of the year. So try to be regular with the problem solving and try to solve the problem of the day each day. It will not only give you consistency, and it will help you in developing your problem solving skills, but also you'll be getting some good hoodies from Geeks for Geeks. You can check that out like here in the problem of the day section, right? Thanks a lot everyone for watching, and make sure to like, share, comment down your how many problems you were able to solve. If you solve the problem of the day for today, make sure to comment down in this video, and I'll see you tomorrow in the problem of the day for 9th of